this episode of TPJtv, we're in Elgin, Illinois at the headquarters of Mazak Optonics Corporation to talk about trends in steel usage for non-residential construction. Today we're going to interview Bill Citron, president of the company. I think our viewers are familiar with I-beam, H-beam, and C-channel, but tube and pipe have been making quite a bit of headway in non-residential construction in recent years.
Over the last several years, what is known as HSS, which is a hollow structure section, has been making very serious inroads for non-residential construction. The weight to strength ratio in hollow structure sections is significantly higher than in what's called wide flange, such as H-beam or I-beam. Actually, they're about 23% stronger in their ability to withstand pressure in relationship to a wide flange construction section, and in addition are 51% less weight than the wide flange. So it's very, very economical to use this type of HSS in construction.
Those are pretty substantial differences, and there's also the aesthetic considerations, correct?
Well, they don't have, they're much easier to finish on the outside. They're much more aesthetically pleasing, and they're very easy to paint. So in areas like airports or art institutes, any place where you have a wide, clear span and you're looking for high strength in structures, the HSS works extremely well.
Now, these really took off years ago in Europe and Asia, I believe, and that trend is now getting to the United States. Is that correct?
Yeah, architecturally, we've been behind the rest of the world in the use of HSS. However, what we've seen recently as far as new buildings and new public facilities using HSS has grown dramatically.
Okay, so residents of Cleveland would recognize this at the Rock and Roll Hall of Fame, I believe?
Yes, the pyramid at the Rock and Roll Hall of Fame is made primarily of 4-inch, 6-inch, and 14-inch HSS combined with glass. It's becoming popular, and it's becoming popular because you can get a wider span with lighter weight, which means less cost.
Some of the difficulties in using HSS have to do with the angles at which the two pieces meet and the very precise bevel cuts that need to be made so that the welds get full penetration when the constructions are assembled.
In our own facility in Japan, we put up a 125,000 square foot building using HSS and making them into what are called space frames. A space frame is a three-dimensional truss for holding up the ceiling on a wide span. Now, the span at our facility in Japan is well over 30 meters, and it's with no columns in the center. The people who actually constructed the building told us that by the use of HSS and the space frames, which are slot and tab designed, reduced their assembly time by over 80%. That's an amazing number, but it's actually a reduction of 80% in what they anticipated the time to be for actually putting up the roof. And it's been used probably on 2 or 3 dozen other buildings in Japan because of the success that we had at our own facility. And what makes this a very reasonable way of construction is lasers. And specifically, our lasers are meant for heavier HSS sections, although we can do the wide flange, we can do H-beam, we can do I-beam, we can do C-channel. But the advent of HSS has really made the use of tube lasers prominent in the industry. The fabric gear starts with a set of V-arms for the new pieces of material to be loaded in. They can be in any order. As you can see here, we have both round, rectangular, and square parts all being loaded at the same time. The chuck that you see down at the end will come in, grab that part, and move it into the fixed chuck, which is inside the machine. The chuck here on the right end, which we call C1, actually does the control of the rotation. The other chucks work as slaves to it. And this is what gives you the exposure to the torch of the different parts of the HSS structure or wide flange structure. As you look inside the machine, what you're seeing is the fixed chuck, which acts as the support for the workpiece as it passes through the laser area. Inside there is a 5-axis laser head, which can do a full 3D complement of cutting, as well as a 6-station turret with 6 tapping heads. So we can do up to 1/2-inch thick and 1/2-inch diameter taps in holes that have just been cut by the laser. One of the unique features of this machine is that beyond the cutting area, we have 2 more chucks for supporting the part on the outgoing side, which allows for much more accurate processing of long parts, slots, other tap areas of the structure. But it is that unique feature that supports and gives us a tremendous amount of accuracy in the processing. Here we are now on the outfeeding side of the machine, where chucks 3 and 4 can continue to control the workpiece very accurately and then offload them onto another set of V's. Each one of these V's that you see out here is another controlled axis. So the accuracy of the parts that are made on this machine are higher than most that you would see in this industry. Some of the parts that you can see down here have very complex cuts. And although what you're looking at here, all these cuts are normal, meaning perpendicular to the work surface, which is a very common way of doing this. But what we can also do is, with special software, we can program what are called penetrating cuts, which allow for the integration of a separate workpiece to pass through the pipe, and it will pass through at exactly the angle that it's programmed to. This allows for extremely complex workpieces. When we're talking about thicker wall material, such as what we've got right here, the advantage of a laser is dramatic in the amount of time that it can save the processor. These bevels here would normally have to be done with a large countersink. These holes would normally be drilled and then milled. By passing them through with the laser, they're done in seconds versus hours. Machining this type of material is very common, but in the processing with laser, it is so much more productive and as a result, much less expensive for the processor.
As you can see, laser cutting machines are a good fit for the steel construction industry. For TPJ TV, I'm Eric Lundin.